Kia ora and welcome to my little video on exponential patterns. Okay, so in this little clip I hope to go over how to create an exponential equation from a particular pattern of numbers. So our most basic equation of an exponential pattern will look like y equals some number to the power of x. Okay, our general equation could look something like this, where we could have plus something at the end, or we might even end up with something like this. Y is equal to a or r, whichever letter you pick, some number to the power of x plus or minus something. Okay, so I'm going to use b up here, and then you could end up with some constant term. Okay, so there's lots of ways that this equation could look. And when we're trying to work these things out, you're looking for some kind of doubling or tripling or some kind of multiplication or division of some base number to get the next number in the pattern. So let's look at this example here. So I'm not going to go with the first example that's written on here. That's why I've scribbled the y values out and replaced it with another one. So here we've got 2, 4, 8, 16, 32. And like with finding a linear pattern or even parabolas, quadratic patterns, we're going to look for some common differences. However, unlike a linear one and more like a quadratic one, we will be looking at a second difference. So let's have a look. So here, the first difference is 2, the next one is 4, 8, and 16. So there's no real common difference there. However, we still need a common difference. And as you look at these, you'll notice that as you go this way, from the largest numbers to the smallest, that we are actually dividing by 2. Half of 16 is 8, half of 8 is 4, half of 4 is 2. Okay, so that means if we went the other way, then it's going to be times 2. Okay, so our common number here is 2, but it's multiplied. So that will be our base. Okay, so we're going to have y is equal to 2 to the power of x. Okay, now let's just double check that to make sure that that is true. So 2 to the power of 1, that's 2 to itself basically. If you rewrote it, it would be, let's see, 2 to the power of 1 is going to equal just 2 times, well, there's nothing else to multiply it by. So that's why it's going to be 2. Okay, 2 to the power of 2 is like saying 2 times 2. 2 2s are 4. That's our second number here. 2 to the power of 3 is like going 2 times 2 times 2, which is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. So yes, this is our most basic equation with 2 as our base. Okay. Now what if it gets more complicated? Remember, sometimes you could have x plus something or x minus something, and then you could even have a constant term as well. So let's have a look at these numbers that's underneath what I've just scribbled over. Okay, so here we've got 4, 6, 10, 18, 32. Got 4 to 6 is 2. 6 to 10 is 4. 8 16. This is looking pretty familiar. This is looking pretty much like our first one. So, let's see. Multiply by 2? Yes. 4 times 2 is 8? Yes. So it's multiplied by 2. And then we multiply 8 by 2 to get 16. Okay, so our base number is going to be 2 again. So we know it's going to be 2 to the power of x. But, however, let's look at these differences, shall we? So we've got, let's just write that down. Y is 2 to the power of x. But 2 to the power of 1 should be 2. I'll just say 2x squared up here. 2 to the power of x. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16. 2 to the power of 5 is 32. It honestly looks like that these numbers have been shifted. So here we've got interesting differences. So let's look at these differences, shall we? So we've got, it should be 2, but it's 4. So our difference is 2. It should be 6, but our number is 4, so our difference is 2. We've now got 8, but we should have 10. 10 minus 8 is 2. Okay, so it's all out by 2. So in the end we have to add 2 to get each one. So our r is going to be 2. So our y is going to be 2 to the power of x, which is this one here. And then to complete it, we need to add some kind of constant term, which is 2 in this case. Cool. Let's do another one. So we've got 5 and 11 is 6, difference of 6. 11 and 29 is a difference of 18. Nope, sorry. Nope, yes it is, okay. Difference between, 29 and 83 is 54. And the difference between 83 and 245 is 162. Okay. Right. We've got 6 to 18. We could try multiplying it by 3. 3 times 18 is 54, yes. We found our pattern. 54 to 162 is equal to times 3. If you can't see this pattern straight away, what you can do is go the reverse direction. So, what we can do is, well, it's so out of whack, it's not linear. It's not a constant difference, like as a quadratic. What we can do is say, 162 divided by 54 is equal to 3. Okay, so that means we're dividing by 3 to go reverse. 54 divided by 18 is going to be equal to 3. So that means we've got to divide 54 by 3 to get 18. And I know from multiplications that 3 6s are 18, so 18 divided by 3 is going to equal 6, which is our number right here. Okay, so if you know it's going to be divided by 3 going that way, then the reverse direction, or going upwards, is going to be multiplied by 3. So here, our base number has got to be 3. Our r is going to be 3, or if you're learning it by saying your base number is going to be a, then your a is 3. Okay, So it's got to be something, so it's 3 to the power of x, and then something else after that. So let's see what happens when we multiply, when we put everything to the power, when we put 3 to the power of x. So we've got 3 to the x up here. Let's put it in a column down here. So 3 to the power of 1 is just going to be itself, 3. 3 to the power of 2 is going to be 9. 3 to the power of 3, because x is 3, is going to be 27. 3 to the power of 4 is going to be 81. 81 times 3 is 243. 243. Okay, so does that give us our numbers that we had originally? No. Here for the first one we've got 3, we should have 5. Okay, we could always try adding 2 to make 5. We've got 9, we should have 11. Okay, again, add 2. We've got 27, but we should have 29. We can add 2. Okay, so for all of these, we can just add 2, because 81 plus 2 is 83. 243 plus 2 is 245. So our equation is going to be 3x plus 2. Okay, third example. We've got -1 to 11, so our difference is 12. First difference. 59 minus 11 should be 48. $192, and that's a massive number. 19 minus 251 is 768. Okay, I'm just going to pull out my calculator because I can't do that in my head straight away. So 768 divided by 192 is going to be 4. So divide by 4 to go that way. Can I divide 192 by 4? It's going to give us 48. Yes. Okay, 48 divided by 4 is going to be 12. That we can do. Okay, so our base number is going to be 4. Now I can tell you straight away that that's not going to be the same. So let's see, 4 to the power of 1 is going to be 4, but we've got -1. 4 to the power of 2 should give us 16, but we've got 11. Okay, so here, if we subtract 5, we're going to get -1. If we subtract 5, we're going to get 11. 4 to the power of 3 is 64. 64 minus 5 is going to give us 59. Okay, so 4 to the power of x minus 5 is our equation. I'm just going to make that tidier. 4x. Okay, so y is equal to 4x minus 5. Okay, now that we've got our equation, we can just substitute something in. When will the y value be over this? This is a bit harder. I think I'll put this in another video. Okay, thanks for watching.